Okay, hello everybody, what's going on? My name is Muhammad, welcome to another video. So in this video, I'm gonna teach you how to solve for the length of the line segment FB here, which is unknown, okay? So what is given here, we're given the polygon ABCD and the line segment lengths 8. So the line segment CB is equal to 8, CF is equal to 9, DC is equal to 8, and AD is equal to 10. And we're also given that the angle FCB, which is this one here, is the same as the angle FAC, which is this angle here. And also, we're given also the information that the angle ADC, which is this angle here, is twice the angle DAC, which is this one here. Okay, so that is exactly what is given in this question. So based on this given information, we need to solve for the length of the line segment FB here. So that is what is unknown here. Okay, now if we look at the shape here, at the problem here, we can notice that this angle here is a common angle of this triangle here, the big one here, and this triangle. Okay, so we have two triangles, FCB and ABC, okay, where the angle ABC is a common angle. Also, we know that this angle is equal to this angle. So we have two angles in these two triangles that are equal, which means, okay, that the third angle is also equal, which also means that the two triangles are similar to each other. So we can benefit from that, basically, to calculate for the unknown length FB. So if we can go ahead and assume that the unknown length is equal to y, then we can benefit, okay, hold on. So we can benefit from the fact that the triangle CAB is similar to the triangle, BCF. So based on that, we can go ahead and find that the proportion of y divided by 8, y, which is this length here, is equivalent or is proportional to this length here, so divided by 8, okay, is equal to the proportion of this length here, okay, so the proportion of the unknown length y to 8 is the same as the proportion of the length 9, okay, which is this length here, to this length here, okay, to the length of AC, to the length of AC. Okay, so basically, if we can know the length of AC, we can solve the problem. Okay, so let me erase that. Okay, so if we can find a way to find the length AC, then the problem is solved. Basically, y is going to be equal to 72 divided by the length AC. So basically, that's the solution to the problem here, AC. So the problem here is to find a way to calculate for the length AC. Now, how can we find the length AC? So one way to think about this is to benefit, okay, from the angles or the proportion of angles that is given to us in the question. Okay, so what I thought of is that I can extend the line segment DC, okay, so I will sketch that roughly here, okay, in a blue color. I can extend this line segment here, okay, I can extend this line segment here, okay, so that I can form this triangle here, where this length here is equal to this length. So this is going to be 10. And of course, because this is a bilateral triangle, so this side is going to be the base angles, these base angles here are going to be equal, okay? And the sum of the base angles of this bilateral triangle is going to be equal to this exterior angle ADC. So I can go ahead and, so each one of them is going to be half of that, okay? Actually, I have to use, so I have resketched everything here, so I will delete all that because I have already resketched, sketched a ready figure down here. Okay, so this is exactly what I did here. I extended, okay, the line segment DC so that I formed the triangle ADE such that the base angles are equal. So because it's a bilateral triangle, so the its base angles are equal, and the sum of its base angles is equal to the angle, to the exterior angle ADC. So each one of them is going to be half of that. So if we have two red dots for the angle ADC, so each one of the bilateral triangle AED is going to be half of that, okay? So I'm going to be using a small red circle for each one of them, okay? Now, we can go ahead and notice, guys, you can notice here that this triangle here, we have a bisector, an angle bisector here. So we can basically benefit from the angle bisector theorem that tells us exactly that an angle's bisector divides the interior angle's opposite side, which is EC, into two line segments, which are proportional to each other, just like the proportion of the two other sides of the triangle AC and AE. So basically, based on this, we can go ahead and assume that this side here is equal to 10x, and this side here is equal to 8x, okay? And let me erase all that here. And then we can apply, basically, again, Stewart's theorem on this triangle here, okay? We can apply Stewart's theorem on the triangle AEC. So let's do that, okay? Apply Stewart's theorem on the triangle, AEC. So basically 10x squared plus 8x squared equals equals 18, which is the length of EC, so that's 18, multiplied by d squared, which is 10 here, 10 squared, plus the multiplication of the two line segments 8 and 10, so that's 80. To remember, by the way, one of the ways to memorize Stewart's theorem is to remember the statement that a man and his dad put a bomb in the sink. A man and his dad put a bomb in the sink. That's one way to memorize Stewart's theorem. Okay, so now we can go ahead and solve for x. So if we solve for x is going to be equal to 3 divided by 2. So now we know what x is, okay? So x is equal to 3 by 2. If we solve this quadratic equation, then it's a straightforward mathematical manipulation here. We can solve for x. X is going to be equal to either plus minus 3 by 2. Of course, we can pick the positive value. Okay, so that tells us that the length AC which is going to be equal to 8x, is going to be equal to 8 times 3 by 2, which is 3 times 4, which is 12. So now we have solved for the length AC using two theorems, the angle bisectors theorem and Stewart's theorem as well. Okay, of course, maybe we can use other ways to calculate for the length AC. Okay, but I find this is the easiest and the fastest way. Now, having calculated for the length AC, we can apply we can benefit from the fact that the triangle CAB is similar to the triangle FCB. So based on that, the proportion of the lengths of the two triangles are equal. So y, which is the unknown length that we want to calculate for, divided by 8 is the same as 9 divided by 12. So from that, we can go ahead and solve for y. Y is going to be equal to 72 divided by 12. So that's going to be equal to 6. And that's the solution to this problem. If you like this video, hit like and don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching and see you in another video.